Hello, now we have discussion about binary subtractor and binary adder. So here, can you think that why we have taken full adder? If you have not taken four full adder, so what can be the another combination? Okay, just think about this. So here we can have one half adder and three full adder. After that, you are seeing that when we're trying to subtract two numbers, suppose we are going to perform a minus b. So then a is called as minute and b is called as the subtrahend. So now in this scenario, when we'll try to perform a minus b with the help of like here we have used full adder. So that means subtraction we are going to perform with the help of addition. So in this case, we have to take the 2's complement of subtrahend. So here subtrahend is what? B. So we have to take 2's complement of B. So that we are talking here about unsigned numbers. So 2's complement of B we need to take. So that will be the 1's complement plus 1. So finally, if you see that, if you have A plus B dash plus 1, so it is going to perform the operation A minus B. So this concept we are going to use here. So here we have taken the example of the circuit. So that perform the binary addition as well as subtraction both. Now if you may think that why we have taken XOR gate and why subtrahend is only given input to the XOR gate. Why not minute bits are given to the as the input to the XOR gate. So here we are using the concept of the XOR gate. So in case of XOR gate, if we are going to write B XOR 0, then what will be the output? The output depends upon the B. If B is 0, then both inputs are 0, then output is also 0. If B is 1, okay, then one combination is 1 0. So one input, only one input is high, so output is 1. So whenever we have B XOR 0, that is going to be the output as the B. And similarly, if you see that when we have B XOR 1, then what is going to be the output? So in this case, we have output is B dash. Since if you consider B as the 0 and 1 is here, so only one input is high, so output will be 1. Now if B is 1, so both inputs are 1, 1. So that output is going to be 0. So on the basis of this here, if you are going to take M equal to 0, another you are going to take M equal to 1. So when we have M equal to 0, then output of this XOR gate will be simply what? B. So here we'll get the B naught. Here again you'll get the B1 and here we'll get the B2 and here we'll get the B3. Another input is already given. Minute bits are given as the input. So finally it is going to perform the simple binary addition. And M is equal to 0. So this initial C naught also going to be the 0. And this circuit is going to act as the simple binary addition is going to perform. Now if you see the another situation, so in that case, if you're going to take M equal to 1, so already we have discussion. So when we have one input M equal to 1, so then XOR gate is going to perform the complement. So M is 1 and from this side S C naught is going to be 1. So this XOR gate is going to be the give the complement here. This is the B0 dash and it is added with 1. So finally here it will have 2's complement. Okay. So similarly here we have B1 dash and this is the going to give us B2 dash. This is the B3 dash. and 1 is being added here, so it's going to perform the 2's complement. So finally 2's complement of the subtrahend is being added with the minute. So minute bits are given directly to the full header. So finally it's going to perform the subtraction, okay, with the help of full header. So finally conclusion is that when m equal to 0, this circuit will perform the binary addition. When m equal to 1, it is going to perform the binary subtraction. Now suppose for example we are considering a equal to 1001. Okay, so it has base 2. So in the decimal you know that it is equivalent to 9. Okay, and another is the b that we are taking as 0110 in binary numbers. So in decimal it is going to be 6. So now when we are performing here a minus b, okay, so that's why what we have to take? We have to take the 2's complement of b here. So what will be the 2's complement of b? 2's complement of b, you know that directly also you can find. Otherwise you have to find 1's complement and then you have to add 1. So in the direct way, what is the rule? We have to leave the we have to leave the 0 as it is and first non-zero number also as it is. After that, remaining will change 1 into 0, 0 into 1. So here first bit is what? 0, it is non-zero, we'll keep as it is. Second is the first non-zero bit, so we'll write as it is. Next one will change this 1 to the 0 and this 0 will change to 1. So this is the 2's complement, okay, of the subtrahend. Now this 2's complement we are going to add with the a, that is our minute. So 1001, again 1010. Now for these two we will perform the addition operation. So if you add 1 plus 0, what we'll have? Sum is 1, carry is 0. 0 plus 1, again sum is 1, carry 0. 0 plus 0, 0. 1 plus 1, sum is 0, carry is 1. So when carry is going to occurs, that carry we are going to discard and finally obtained number is what? 0011. So this is the finally, this is the binary number, the decimal equivalent is 3. So finally it is the value of a minus b, that is the 9 minus 6, that is equal to 3, you can see. And here if you see that this carry C3 and C4 is connected to the XOR gate. So this B represent the overflow condition. Overflow condition. So whenever B will be equal to 0, it will represent that no overflow takes place. Okay. And whenever we have B equal to 1, it represents the overflow condition. And when overflow is going to occur? When both numbers are positive or both numbers are negative. In that situation, overflow is going to occur, that is detected here by the help of XOR gate. Okay. So this one m equal to 0, it perform the addition. M equal to 1, it perform the subtraction.